Now, we now have the splitting the hexoses. Remember that this fructose 1,6-bisphosphate will now be converted into two things. But let's recap. Remember, we are trying to make pyruvate. So the first process is we are converting glucose to glucose 6-phosphate by adding what? ATP molecule, and we now produce ADP. And which enzyme is doing that? Hexokinase in the muscle, while in the liver, glucokinase. Now from glucose 6-phosphate, we now convert it to what? Fructose 6-phosphate. And which enzyme is doing that? That is phosphohexoisomerase. And from fructose 6-phosphate, we now convert it to what? Fructose 1,6-bisphosphate. And which enzyme is doing that? Phosphofructose kinase type 1. And we are converting what? ATP to what? ADP. Now, an enzyme known as what? Aldolase. Enzyme known as aldolase now converts fructose 1,6-bisphosphate to two things, which is dihydroxyacetone phosphate and glyceraldehyde triphosphate. Dihydroxyacetone phosphate and glyceraldehyde triphosphate. Now, I also want you to observe something. Is aldolase is converting fructose 1,6-bisphosphate to dihydrogenacetone phosphate and glyceraldehyde triphosphate. So glyceraldehyde triphosphate will now proceed to form pyruvate. But our body cannot start converting this dihydrogenacetone phosphate to pyruvate. So our body will not develop a means of converting this dihydrogenacetone phosphate to pyruvate by doing what? Our body will first convert this dihydrogenacetone phosphate to what? To glyceraldehyde triphosphate by an enzyme known as what? The triose phosphate isomerase. So what is the triose phosphate isomerase doing? Triose phosphate isomerase is converting dihydroxyacetone phosphate to glyceraldehyde triphosphate. And it is done by an enzyme known as what? Triose phosphate isomerase. While fructose 1,6-bisphosphate is converted to dihydroxyacetone phosphate and glyceraldehyde triphosphate by an enzyme what's known as what? Aldolase. Now, we have one molecule of glyceraldehyde triphosphate, and if our body starts breaking down this molecule in order to produce pyruvate, we are going to be having one molecule. Our pyruvate will be one. But since our body is converting this dihydrogenacetone phosphate to glyceraldehyde triphosphate, it is now necessary that everything that we are producing is two. Example, imagine if our body can convert this dihydrogenacetone phosphate to pyruvate. What are you going to do? This glyceraldehyde will form its pyruvate 1, and this dihydrogenacetone phosphate will form another pyruvate 1, and 1 plus 1 is equivalent to what? 2. But our body cannot convert this dihydrogenacetone phosphate to pyruvate directly. So our body will now first convert this glyceraldehyde triphosphate by an enzyme known as what? Triose phosphate isomerase. So during this process now, what will now happen? Instead of us having one molecule of triglyceride triphosphate, we now have what? Two molecules. Why? This was one molecule and this was one molecule, but this one molecule of dihydrogenacetone phosphate is now converted to what? Glyceraldehyde triphosphate. And instead of us having one molecule, we now have what? Two molecules of glyceraldehyde triphosphate. And remember, when we have one molecule of glyceraldehyde triphosphate, we only produce one pyruvate. But now, when we have two molecules, how many pyruvates are we going to produce? We are going to produce what? Two pyruvates. If one is producing one pyruvate, therefore two molecules will produce what? Two pyruvates. So for this reason, everything we are going to be producing, both our ATP molecules, both our NAD, our reducing and oxidizing agents here will be two. Now let's move over to the payoff phase, or the NADH and the first ATP generation.